Doing problem C of educational code forces round 122 creative for division 2. So we are given health of the monster, and we are given our health and the damage we deal and the damage the monster deals to us. So the first we deal damage to the monster and then the monster deals us. So let's say if we are given our health of character and our damage of character, and we are given health of monster and int damage of monster. So we have to decide who will win. Basically, will we win? This is the function I'm trying to make. So what I'm gonna do is basically so first we hit, right? Wait, we can actually calculate when it goes on less than 0 by using simple division, and that is so the damage we deal is DC and the health of monster is this. So HM divided by DC is the number of hits it will take to defeat the monster, and uh, hits, let's say hits M, and this is the number of hits the monster will take to defeat us. That will be this one. And since we start first, so if hits hits M is less than hits, so if the monster finishes earlier, like like if the monster finishes us in 2, and that is 1 and 2, and we do not finish in 2, then it should display false, basically return false. And else if hits M is greater than hits, so basically the number of tries it takes the monster to defeat me is greater than, then we can return true. And else, what if the hits M is equal to the number of hits? So in that location, in that, I think we have to return true, because we are actually uh, starting out first, so maybe we will win in that case. Yeah, so we have successfully created a function like this. So the question is doesn't end here. The question is that we can actually buy some health and damage, right? And we can use K coins to buy them, and with each coin our health is increased by A time, and our attack is increased by W if we spend a coin on the attack. So let's find if, let's say if we will win without even buying anything, right? And we have to pass HCDC, HCDC, HM, TM. Wait, I forgot all of these are long, so might have to change that. How do I change that? And I have to change it to long. But this one, okay, these two are not necessary. So if we will win with normal constraints, then just display yes, we can win. and if we do not win with this, then we have to optimally choose the health and the damage increase, right? Okay, now this is going to be difficult. How do I choose the optimal way? So let's say if we choose x amount of for int I, should we take I? Yes, we can take I. Let's remove this. So let's say I0, I less than k, and I plus plus. So what I'm saying is, if we spend I coins on health, then we can spend the k minus I coins on damage, right? And we can go on up till k, so the time complexity will be k times just k, O of k, right? I think this should work. So what I'm gonna do is, so do we have to reduce the minimum? So we can spend k coins, right? So if will win, so we are spending I coins on health, so our health of character will increase by I into the A, and let's make it in commas, although Bodmas rule is followed. And the damage, where is the damage one? So DC plus, so k minus I, and this should be multiplied by W, and comma, the monster's health, right? And damage of monster, right? If this is true, then we just flag to be true and break. Let's take a bool flag equals false, and if flag is true, then see out as yes. No, let's run this, and this is useless. Its M was not declared. I just declared that, bro. How's it not declared? That's a bit weird. Okay. This has to be its M. Yes, no, yes. I think this works. Shit. But how can it be wrong? Oh wait, we can actually take K. Fuck up. Can we submit in within 5 seconds? Okay, let's not fuck up this time. Let's make sure we are correct. So our damaging is increasing by this much amount. Yeah, looks good to me. What? This is impossible. Hmm. So K is a lot large, but that should be fine. Okay, let's see. So health of monster divided by the damage we do, and health of character divided by the damage the monster does. What could go wrong here? I think this is actually unnecessary now. I don't know what's wrong. Do we have to use binary search of some sort? Hmm. But it's not TLE, it's just a wrong answer on test 2. Okay, so the hits it requires, the monster requires to kill me is less than the hits I require. Then it's probably true, right? It's probably false because it it is like, let's say I finish him in 2 hits and it finishes me in 1 hit, then he wins, right? So we say false. And if I basically I finish him faster, if I finish him faster, then I return 2. And if we both are the same, so let's say I finish him in 2 and he also finishes me in 2, so still I'll be the first one to finish because I am the one that is starting the attack. Why is this not working? Oh, okay. Okay, let's see. So long menda x is equals to hm percentage tc. So let's say if, oh okay, we might have leftover, obviously. How did we forget that? Health of character divided by the damage of monster. Okay, so we could actually just check if m hits is not equals to 0, then we increase rem hits, basically hits plus equals 1, because the remainder is not 0. That means we will actually require one more hit to kill that person, and if rem hits m is not equals to 0, or we can also say greater than 0, and let's just say it like not equal to 0, then again we increase the hits of monster by 1, right? Then this should be fine. Why is this not running? Okay, it got accepted. Yeah. So let me discuss the problem B also, or should we just try D maybe? You have an array of integers a of size n. Let's try D and E before we actually give up and go after discussing solutions. Okay. You have an array of integers a of size n. Initially, all the elements of the array are equal to 1. You can perform the following operation: choose two integers I and x, and then increase the value of ai by ai divided by x. This the lower bound of that. Wait, what is x? Two integers, value of a of I by x. So x is any number. Okay. So x is greater than 0, that means it can be 1. So at least we can make 1 go to 1 to be 2, and then we can maybe increase it by 2 again, and then this 2 can go to 4, and so on. Perform all operations, you will receive ci coins for all such I, such that ai is equals to bi. What? Your task is to determine the maximum number of coins that you can receive by performing no more than k operations. Okay, I don't understand the question well, but let's just write the template code. So we input n and k, where n is the size of the array and k is the maximum number of operations. Second line contains b array, which there is no discussion about. So I should essentially make it a capital B. Okay. Then third line contains n integers, that is ci. What is going on? Just copy paste this. Okay. So bi is less than equals to 10 to the power 3. That is weird. Okay. You have an array of where is a? 1. You can perform the following operations. Oh, okay. I get it now. So basically, A of n, let's take it a vector. A, this is of n size and is initialized by 1. Right. So essentially, every element of A, we can make A of I equals to B of I. Then we get Ci coins. And we can do no more than k operations. What is a one operation? One operation is changing any integer, choosing any element ni and increasing it by ai divided by x. So this is the question, and at most we can increase it by its own value, basically multiplying the number by twice, because if we choose x optimally. So for maximum increase of k of I, x should be equals to 1. Basically we are multiplying the number by 2, and let's copy the test cases. Okay, can we make any number out of a of I divided by x? Like if x is 1, then we can just add a of I, right? And if x is 2, then we can add a of I divided by 2. And if x is 3, then we can add a of I divided by 3. And this is, if these are not divisible, then this is just lower bound. What do you call it? Floor of this? Floor? aka floor of this. Now this just made the question a hell lot difficult, because I thought, let's say if a number is 6, then we can make it 12. But what if we want to go up till 11? Then we can't make 11, right? Because we can only increase by either 6 or we can increase by 3. So we can make it 9. Oh, wait a second. If we can go from 6 to 9, then maybe we can go to 12 or 11. There are a lot of questions in my mind. Yeah, actually we can make it anything, because we can actually choose x to be the value of ai, right? So if x is equals to a of I, then we can actually increase it by 1, but we can make at most k operations. Now that will be difficult to imagine. Okay, there is no explanation of the test cases. Amazing. How do I deal with this? So let's see some test cases. So n and k. So we have 4 elements, and we can do 4 operations at max. And we are given the p of I. We have to change the RA2 and c of I. So we can see that we have already accomplished the b of I to be 1. So it is already 1. So we don't have to change that. So we already get we get 2 coins, right? So we get 2 coins from here. And for 7, I don't think we can make 7. Think we can make 5 using double. So basically we go from 2 to 4, and then we can go from 4 to 1. 4 plus 1, that is 5. So this will take 3 operations, and this will take at most 1 operation. So 3 and 4 operations. So basically you get 5 plus 2, that is 7. 7 plus 2, that is 9. So that is the explanation of the first test case. Now how do I do that? I think this is out of my reach. You are given a connected weight. This seems even more difficult actually. And this is obviously difficult. But I really want to try these also. 40 minutes left, and I've not been able to come up with an algorithm for this one. Because any algorithm I'm able to think of is of a larger complexity. Like, which of the elements should I go for and why? It's like I can make two. So let's figure out what are the costs to make each number r. So we can maybe make a vector, we can make it int, and it can be costs and n comma 0. Let's say what is the maximum value of n. So n is maximum is 1000. Oh, that's weird. Oh, n is at most. Okay, so n is actually the size of the array and not the. Okay, so b of I is also 10 raised by 3. Weird. There has to be some. I think I can go with the worst case complexity maybe. Then. So first of all, we can get away with all of the plus ones, maybe, right? So I into is equals to 2. We can remove this and we can say int steps equals 0. So initially cost of 0, cost of going up to 1 should be 0, right? Cost of going to 1, cost of going to 2 is actually 1 because we can just double it. And cost of going to 3, what is that? Cost of going to 3 is 2. Cost of going to 4 is actually 2. Cost of going to 5 is actually 3. Cost of going to 6 is actually, so we can go from up till 8. I think it will be 3, maybe. No, it can be different, right? Because we can go up till 4, and now we can't add 1 We can add 1 twice, so this will be 4, but can we do better? So to do a better one, that means we need to add 2 to it. So it can be done, right? Because 4 divided by 2 is 2. So it can be done in 3 steps. Cost of 7, but what is the formula, guys? I'm not gonna do it until 1000. I'm not able to observe a pattern up till now. So cost of 7 equals maybe cost of 7 will be, so we can go to 6 up till 3, so we can obviously do 4. 4 is like minimum, but can we do better? The question is, we can go up till 4 by 2 steps, and we can go, no, we can't, we can maybe, okay, 4 divided by 2 is 2, 4 divided by 1 is 4, and 3 is purely like 1, right? So this is giving me 1, and 2 is giving me 2, and that is giving me 4. So there is no 3, so we have to make it 4. So cost of 8 is, we all know 3. Now here is what my prediction failed. So I thought up till 8 everyone would require 3, and that is not the case. I'm now scared for my life. Okay. So essentially what I'm able to observe is that going up till 1, 2, that number that we have achieved. Wait. So it's already actually we can make it. No, we can't. But we can actually go from here to anywhere, right? We can go from 1 to 2, 2 to 4, and God knows where. Okay. So we are at int location is equals to 1. We are at 1. For int I is less than location I plus plus. So int steps equals 0, 1, 0, right? Yeah, so I get it. So we can, in one step, we can go to all of the locations, basically location plus um, location divided by x, so we can cover all the x. So this is basic, I is basically representing x here. So currently we are at location, so we are going to make the cost of location plus location divided by I to be equals to the current steps plus 1, right? So it took me 0 steps to reach 1, and for every number from this to this, and it will take these many steps, and after this every iteration we are going to move to where do we move to? No, that's weird. Okay, equals to 0, I is equal to 1, I less than 1000, and less than equals to I plus plus. This is the reason why it's actually, we don't actually have to go up till this, right? So basically location is basically I, and if cost of I is already not equals to 0, so we have actually reached that spot somewhere before, then all we do is this thing, so the current location becomes I, the steps becomes cost of I up to reach that step. So this should stop at around, so when can we stop it? So 10,000, so 1000 divided by 2, that is, right? So this should be the stopping point, I believe, right? Looks good to me. I don't know about you guys. Yeah, so we created a cost dp maybe, and now we have stored the number of steps required to reach every number from 1 to 1000, and 1 basically being 0. And let's display this cost matrix. I'm really curious about if I have created this perfectly or not. Let's see, it's gonna be fun. And if we don't solve it, we don't have much time available. 29 minutes. Shit. What happened? Vector was not declared. I really want to see all of the questions in this educational Codeforces wrong, because it looks really nice to me. So it is okay. So to reach 0 it's 0, and to reach 1 it's 0, to reach 2 it's 1, and let's see, let's compare it with this 1 2 2. Oh no, it's wrong. It's wrong, guys. It's wrong. It is wrong. It's wrong. Let's say we can actually make it minimum of steps plus 1 and the already cost. No, then the cost will be 0, right? What do we do then? If the cost of location plus divide by I, this is vacant, that means this is equals 0, then we can do this maybe. Because this is not reached in 3 steps, this is 3, right? So 3 is reachable in 2 steps. Yeah, 1 2 2 3 and 3. Oh no, again. Okay, it's right. 3 3 4 3, and then for 9 maybe it is. Let's display the I also. Let's display the I just to make sure that we are doing it correctly. So for 8 it is 3, correct, and 9 it is. I love that it has predicted that 7 is actually equals to 4. I hope this is correct. Yeah. Okay, so now that we have done that, we actually know that to reach that location how many steps it's gonna require. So now what do we have to maximize is we can do at most k operations, right? So what do we maximize on? Do we maximize it's like a knapsack problem. Okay, so do we maximize the number of locations that have b of I, or do we try and make the ith location with most amount of reward to be correct? That is the question. So let's create another matrix called int d of n, and what we do is int I is 0, I less than n, plus plus, and basically see what we do is d of I will be equals to b of I, and we pass the cost of this b of I in this one. So now we have a cost array basically. We have the cost and we have the, so basically it converts into a knapsack problem. So the knapsack, I don't know how to solve knapsack problem, to be honest. So in this knapsack problem, the weight of the, let's say the knapsack, or whatever you call it, the bag, is equals to k, and the weight basically the d is having the weights, and yeah. So I'm just gonna Google solution C++. So is it a 0 1? Yeah, it is a 0 1, right? are there so many implementations of the same thing? Okay, let's copy this code. Number of items in a knapsack. Is it? Wait. What does this mean, number of items? Oh, okay. Got it. So in my case, the number of items in the knapsack is basically, I need to edit this code, remove this, and in main function, basically number of items, N and W. What is W? What is W? So capacity is W. Comment this. Comment this. So N is the number of, and W in my case is K, right? So I'm just gonna make this K, and N remains as it is, and the weight matrix is basically weight matrix is, what is the weight matrix? D, right? D, and the values is C. I hope this works, and we can say less than endl here, and I can just copy this and paste this right here as the solution of my problem for each test case, and then I can just include these functions. I don't know how to code these, but I can use them in my program. I hope this works. How do they include DP in this, by the way? Okay, 7 is wrong. Why is it coming out to be 7? Weird. So I think it is not recognizing this. So 1 is 0. Oh my god. Oh, it was almost correct, but it just fucked up somewhere. What is the issue? Cost of 1 is 0, right? Oh, wait. We did not remove these. And we were printing out that shit. So it might have been true that this cost function might have been wrong. Weird. Let's see what is happening right here. Location is I. Location is I. And we go up till location. Let's give it value of int max maybe, and this to be minimum of steps +1, and cost of basically this thing. And we can move this. Still wrong. Why is this happening? I don't know, man. Why is this happening? Let's see the DI array. And let's remove some of these, right? Let's remove this and then try 7030167 segmentation fault. Why is that? How can it be a segmentation fault if I've just removed this? Now that's weird. It was a segmentation fault for no reason at all. Okay, so the cost is 0 for this one and 4 for this and 3 for this and 1 for this. Then why isn't my code taking it? So maybe the problem is in the knapsack one, right? Now I don't know how to change this code. Value and then wait. Okay, so maybe a value should be here and then weight should be here. Maybe. No, the weight is here and value is here. What is wrong in this one? I don't even know what I'm doing wrong. Time is running out. Okay, let's see what is the knapsack doing. So it is creating I comma weight, and it is generating some k matrix, and then it goes from I equals 0 to n, and for every weight, if I is 0 or weight is 0, k of I is 0. So what is the k value, k in this case? I think this is the place where it is hurting, right? Because if the weight is 0, wait, why is saying this should not be there? Oh, maybe this works. Okay, problem D. Let's read the problem E. So you're given a connected weighted undirected graph consisting of n vertices and m edges. You are asked k queries about it. Each query consists of single integer x. For each query, you select a spanning tree in the graph. What is a spanning tree? Let the weight be this. Okay, this is out of our range. Shit, wrong answer. That hurts. I guess we tried. That is what we get. Okay. You're given a tree consisting of n vertices. Number from 1 to n and n minus 1 edges. N vertices and n minus 1 edges. Initially, all the vertices except vertex 1 are inactive. Queries of 3 types. 1. We activate the vertex V. It is guaranteed that the vertex V is inactive before the query and one of its neighbors is active. After activating the vertex, you have to choose a subset of edges. A subset of edges of the tree. Subset of edges such that an active vertex is incident to exactly one chosen edge, and each inactive vertex is not incident to any of the chosen edges. In other words, this subset should represent a perfect matching on the active part of the tree. If any such subset of edge exists, print the sum of indices of edges in it. What? Second, queries of this type will be asked only right after. 8 minutes left. I can't solve this one. Like, what do I do here? This is straight up. Hmm. Okay, I think maybe I get it. What if there are some places there is a zero left, right? But that will be covered by some or the other. Let's try and remove these what we have given, and let's display what the cost is, right? Let's display the cost, and then we can see maybe segmentation fault. Okay, what is the segmentation fault? Weird. Why is this value? Okay, this is int max. 0, 1, 2, 0 it corresponds to 2 corresponds to 1, and so on. Let's make cost of 0 to be 0 for time being, just to understand this table. Let's see if anyone has a 0. No, right? No one has 0. No one has a 0. And 256 maybe can be reached 10 steps. Okay. So 2 can be reached in 1 step, 3 can be reached in 2 steps, 4 can be reached in 2 steps, 5 can be reached in 3 steps, 6 can be reached in 3 steps, 7 can be reached in 4 steps, 8 can be reached 3 steps, and so on. Wait. What do I do? I don't know, man. This is the optimal. This is the correct solution in my opinion. What could go wrong? I don't think. I don't think. I don't think I have made any mistake. But I have certainly. Hmm. 2 minutes left. Shit. Fuck. I really need to know learn knapsack. Hmm. Let's see if changing the knapsack code works. Here also they have used W equals 0. Why do they exclude the W0? Similarly here also. And here also. Okay, let's see. We can make the this to be 1, and then we can maybe reduce the cost, and we can make maybe this holds some value. I want to submit. What happened? What happened to my code? Shit, what the fuck? Or. Fuck, this was or. Let's see. Let's see. Did I just miss the contest? Okay, let's discuss problem A and B then, and let's just end this. If you have come for A and B, and which is highly unlikely that you have joined this stream for solution of A and B. Clicked on this video, sorry. So let's A, B, and let's C also. C I have discussed, and so in A, basically what I did was, this approach might be wrong or maybe really different, but what I essentially did was, after seeing the input, it said that the number is either a 2-digit number or a 3-digit number. So what I did was, I created every number that is a multiple of 7, and if it's a 2-digit number, I pushed it in the vectors 7 multiples, and if it is a 3-digit number and it is a multiple of 7, then I pushed it into this vector. So now what I did was, I inputted the n, and if the n is already a multiple of 7, just display it as it is, and if it is not, then if the size of that number is 1, that means it's like a 3 or a 5, then the only single digit number that is divisible by 7 is 7. And then what I did was, checked every double digit number and compared it with this string, and whichever had the basically minimum difference, and I used a calculate function which returned me the basically the difference. Let's say if there are two strings 377 and 477. So if the first index at the first index the strings do not match, then it increases the difference count by 1. So this is basically diff count. So if the difference is really low, that is less than 2, so at max it can be 2, um, um, because let's say the integers, so the strings differ entirely, so uh, and the number is of 2 digits, so the maximum it can be 2, and if it is less than 2 then it just replace it by that number that is producing the lesser difference count, and just display the answer string which has the minimum difference count with the given number that is divisible by 7, this answer, right? So similarly I do this for every 3-digit number. I should have made this also a function, but that's fine. Yeah, so that was problem number 1. So you first have to read the problem number 1. That I forgot to introduce the problem if you haven't, but you probably would have. Okay, and this, okay, there are some changes. Contiguous, okay, and contiguous. Obviously, a substring is actually consecutive or contiguous. It kind of the same thing. So we understood the gist. Okay, so in this question, you are given a string of zeros and ones, and you can remove the minority of any substring of. So, so first we take any substring of s, or we can take the entire string also, which I have taken, and because an entire string is also a substring, and what the algorithm states that is that you have to choose a substring and you can remove the minority element in it, all of the elements that are minority in it, which means that if the 0 is in minority then you can remove all the zeros, and if the ones are in the minority then you can remove all of the ones. So what I did was I just took the entire string as the substring, and I counted the number of zeros and ones in the string, and if the number of zeros and ones are not equal, then obviously we can take the entire string and we can remove the minority of them, which is what I've done here. Remove the minimum of 0 and 1, whichever appears lesser number of times, and if the number of zeros and ones are same in the string, then we can just remove um, the minimum of zeros and 1 and subtracting 1 from it, because actually this is also not required because 0 and 1 are same, so it should be just count of 0 and just subtracted by 1, and this is the number of digits we can remove. Because why is that? So take any string that has the equal number of zeros and ones. Let's say it is 0 1 0 1 0 1 0 1. Okay, all right, and what we can do is eliminate the last integer, and after doing that the one of the digits will become a minority, and it actually does not matter which one becomes the minority or majority, because we just have to output the how many numbers can we actually remove from the string, and that will be the one subtracted from the earlier number of zeros or ones that were in minority, or that was same, right? That was same, so just one subtracted from those, and that will be the minority. So if we remove one, then one will be the minority, but it does not matter which one becomes the minority. We just have to display what will be the count of the numbers that we will remove. Yeah, so that was problem number B, and yeah, that was it. Let's see, and let's try and submit this again, because if it's not the solution, Okay, we can submit this maybe. Okay, let's see if we have already submitted this. Okay, okay, okay. Let's try and submit this. Come on. We have done this one. Okay, so this is maybe some kind of error in this. Okay, that's it for today. I think I'll watch the solution of these. I think there was a live stream that was going to happen after this. No, I don't think this is related to this. And there is no editorial till now. So yeah, I think I'll just end the stream now in the video.